Hello everyone, welcome back to our engineering mechanics dynamics class. Today we're going to solve a dependent motion example that will involve a pulley system. So let's um, see what is our learning objective is. So today we're going to solve a dependent motion problem of two particles. Here instead of a particle we'll use a car and a wooden box that will represent a particle. In this example, we'll apply the concept of dependent motion between two particles to determine the velocity and acceleration of one particle given the other. From the picture, it says that it involves a pulley system, and then we'll use a car to pull something using that pulley. So let's see what's the problem is. So the problem says a car is lifting a wooden box. In the picture, you can also see that from ground. So the box is initially was at the ground, using a small pulley system, which is fixed and 30 meters above the ground. So what it tells us that this length here from the ground is 30 meters. Determine the upward velocity and acceleration of the box when it is at 15 meters from ground. So this distance here from the ground, 15 meters. So when it's 15 meters, they want us to find the velocity and acceleration. The rope is 60 meters long. So by rope means this rope here is 60 meters long. One thing to notice is that it says a small pulley. So we're not. So this pulley is too small to. So we can neglect that, and we don't have to worry about the length covered by here. So it's a small pulley. So it says, and the car is moving at a constant velocity of 1 meter per second. So what it means is that the car here, this car is moving this direction at 1 meter per second. Okay, so we have understood the problem. Let's find our knowns. So the velocity of A, the car A, is given 1 meter per second. It's on the right. Length of the wire is given. The rope is 60 meters. So these are the given what are unknowns. So it says at elevation of 15 meters. So when the box is 15 meters from the ground, find the velocity of the box and the acceleration of that box. So before solution of this dependent motion problem, first we have to find a datum. To find a datum, we can find any fixed point. We cannot take any moving point. For example, we cannot take the car as our datum because it's moving. So we can take either C or any base point. So we're gonna take this point as datum. So the car distance will be measured, this arrow X, and the box distance will be measured from this point as a Y here. So this will be our datum or our origin to calculate the distance. Okay, so that's our datum. Now we know for a dependent problem, first we apply the position equation, which is the rope length in this case. So we can see the rope length L, the entire length L is BC. So this BC and AC, and it's a very small pulley, so we don't worry about this part here. So BC, this length, and CA or AC is length is the entire length of the pulley, and that's we assume. So BC, what is BC from the datum? BC is 30 minus Y, because we know this is 30. So BC or CB will be 30 minus Y. AC, what is AC? AC, so we can apply the Pythagorean law here from for triangle, this triangle, we don't know x. So for AC, if we apply the Pythagorean law, so we'll have 30 square plus x square root, all of those. So we'll get the AC. So we have found BC and AC. Now let's plug back these two into the equation. So if we plug back, we found this equation. So the L is 60, and we plug the value of BC and AC. So this is the equation we're gonna use. So with this equation, we made a relationship. If you solve this, simplify this equation, you will get this equation. So this makes a relationship between x and y, and we're gonna use that to solve the problem. So we're gonna use this equation to solve the problem. So next, let's work on the velocity. So to take the velocity, we know that if we take the derivative of the position, we'll get the velocity. So we'll take derivative of this equation. So to get the velocity, dy over dt with respect to time. So dy is this equation, and this is constant, so that's close to 0. So how we get there, I'll show you. So this one is 30 square plus x square to the power half. If we take derivative, it becomes half 30 square plus x square, negative half, because half minus 1 is negative half. And for this x square, for the chain rule, we'll be multiplying with twice x, because the derivative of x square is twice x. And since we're taking derivative y with respect to time t, and we have a different variable x, so we'll have dx over dt, and which is the velocity va, because in x direction it's car A, so dx over dt will be a. So if we simplify this, and this 2 cancel out, so we'll be left with x va, and on the bottom, because it's negative, so 30 square plus x square. So this is how we get VB in this form. Okay, so let's find the velocity, because the problem asks when y equals to 15 meter, find the velocity. So when y equals to 15 meter, if we plug this value 15 to our equation, the yx equation that we derived in the previous slide, if we plug y equals to 15 meter, we'll get let me show you. So yeah, if we use this equation, if we plug y equals to 15 meter, we can find x, the value of x. Okay, so when we plug this value y15 and x 33.54 in this equation that we just derived, taking derivative, we'll find the velocity of VB, which is 0.75 meter per second. Now let us work on the acceleration part. We know if we take a second derivative of the position of a first derivative of the velocity, we'll get the acceleration. So acceleration would be AB, the dy whole square, second derivative of y, which is the first derivative of the velocity equation. So I just plug the velocity equation here, and we have to take derivative, first derivative with respect to time. This derivative is a little bit complex, and so let's see how we get there. So if we take the second derivative of the equation, our terms becomes huge. And now let me explain it how we get this. We're going to apply the chain rule. So we have three terms. just notice carefully, x VA and this 30 the square root term. So we're gonna do one at a time. So we'll first leave these two, x and VA, same. So we leave this part same, and we'll be working on this part only. Since it was in denominator, so the power was negative half. So if we take derivative, we got negative half multiplied by the 30 square plus x square, which will be so if we take derivative, there will be minus 1 added to the power, so negative half minus 1, that will lead you to 3 by 2 negative. So that's why it's in denominator, and the inside x square will take a derivative, so it becomes twice x. So twice x, these two cancel out, so we are left with this x. And since we're taking derivative of y with time and we're dealing with variable x, so we have to add dx over dt, which is in term the VA, and we have the term that we have not touched, this term. So this is how we get the first term, and then the negative comes from the negative half of the power of this term. Now the second and third part is kind of easy. Now we're gonna leave this part, the denominator part, same, and we'll leave the VA, the last term, same. We're gonna deal with only the x, the second term. It's simple, dt dx over dt. We're gonna take the derivative. It will just put in this term, which is also be VA. And for the third term, which is also easy, we're gonna leave the first term, which is this one, same, and we also leave the second term untouched, the x untouched, and then we'll have the dVA over dt. We'll leave it in a derivative form. Now the thing is, so how do we simplify this equation? So we have found the three big term from taking derivative of this velocity. If you see this term here, dVA over dt is velocity. Now the question says the car is moving at constant velocity, so this terms becomes 0. So now we are left with only, so this term is 0, meaning entire this term is 0. So we are left with only these two terms, and what we have to do is to mathematically solve, simplify it. If we take the denominator as a 30 square plus x square 3 by 2, so on top we will have x, and dx dt is the VA, and there's x VA, so x square VA whole square, and then there's negative, plus, since it is half, so we have to have 30 square plus x square to balance it, so we'll have VA whole square. So you see these terms cancel out this term, and then we'll have 30 plus v square. So that's how we get this term. So this is the simplified term of acceleration AB. Once we have that, once we know how to find this derivative, now it's simple. We're just gonna have to plug the value at x equals to 33.54. We're just plugging the value into that equation, and we got acceleration at 0.001 meter per second squared. So we have found our velocity and acceleration. The problem is easy, just plugging your findings into the equation, but the derivative was kind of critical, but we explained that. So and that is our answer. So in next class we're gonna solve a relative motion example. Till then, see you. Thank you for watching. Bye.